So lesson 4.3 is all about standard form, and we are going to split that over a couple of days. And the focus today is going to be about writing the equation in standard form given different types of information. So very similar to the last few lessons, we're just doing that for our third and last form. So we've done it for slope-intercept, point slope, and now we're going to do it for standard. So just a reminder that standard form looks like that. Ax plus by equals c. We used it in the last chapter for graphing. We introduced it. We graphed with this particular form using the intercepts, and it gives you a quick way to find the x and y intercept and whip up a graph. Also, word problems, certain word problems really lend themselves nicely to this form of the equation, especially when x does not necessarily affect y, or y depend on x, but rather it's just two choices or two options. So we're really going to focus on writing linear equations if we start off with something in slope-intercept. How do we get from slope-intercept into standard? How do we get from point slope into standard? Okay, how do we get from just being given the slope and a point and write a standard? From a graph, write the standard from two different points. So lots of different sort of information options if we're given any of these, how we can get here. That's the goal for today. Okay, so we're going to recall that the equation ax plus by equals c is the standard form of a linear where a, b, and c are real numbers, and both a and b are not zero. One can be zero. We know that if like one of these is zero, then we have a horizontal line or a vertical line, but we can't be missing both because then we don't have any variables, right? And all linear equations should be able to be written in standard form. In addition to writing it, we're going to focus a little bit on making sure that when we write it in proper standard. And I introduced that a little bit in the last chapter, but with the graphing, it wasn't really a big deal. But as we write our equations in standard form, we are going to also focus on making sure that we write it properly. And that means that a would be a positive whole number. Okay, and it means that a, b, and c have no common factors. So as we write our equations, we will practice writing it in proper standard form. Okay, all right, so let's go ahead and get started. From slope-intercept or from point slope. Okay, the linear equation that is in slope-intercept or point slope can be written in standard form by using the different properties of equality, addition property, subtraction, multiplication, and division property of equality, so that we can rearrange the original equation into proper standard. So it's about reorganizing things so that instead of the y value being isolated, the x term and the y term are together, and then the constant is the only thing that's by itself on the other side. Okay, so let's try it with number 1 here. We have y equals 3x minus 5. We want to write that in standard form. So again, standard form requires the x term to be on the same side as the y. Okay, so to get it in the right order, and let's write that down, we're going to move the x term. So write this down. Move the x term to the left. That's step 1. Okay. Once it's on the left, then really all you have to do is make sure that you get it into that proper form that we're going to practice. So then put it in proper form. Okay, so let's see what that looks like. Here, the first thing I'm going to do is move the x term to the left. So intercept, all we'd have to do to get in standard is move the x term. And that, so I'm going to do the opposite sign, negative 3x, and it cancels it on the right side. And now the x term is on the left with the y. There we are, right? And really, you're already in the organization for standard. You've got that ax plus by equals c. You have the x terms together with the y term on the left. So the order is already there for you. And really, it's about putting it in proper form. So let's remember what that means. That means we're going to make sure that the a, the leading coefficient on that x term, is a positive whole number, and that these guys don't have a common factor, okay? So I notice that this is negative, so that's what I want to fix, basically. I want to make sure that that a is a positive whole number. So I'm going to multiply the entire equation, and that's the catch. Make sure you take it all the way to the end, or to the other side here. And all I have to do now is multiply by a negative, or a -1, all the way across. And that changes all the signs. So a negative times a -3 is a positive 3x. -1 times a y is a negative y, and a negative times a -5 is a positive. So basically just switches all of our signs when we multiply through by that -1. And then the other thing I need to make sure is that we don't have any common factors. So my coefficients are 3, -1, and 5. And in fact, all of those are prime, so they definitely are not going to have any common factors. That is all I had to do. This is standard form for that same equation that we started in slope-intercept. So y equals 3x minus 5 would be the equivalent of this equation, but it's just written in standard form instead of slope-intercept form. Okay, so let's try it again on B here. So we're in slope-intercept. All we have to do to get in standard is move the x term to the left. So we'll do the opposite sign here and move the x term so that it is on the left side here. So now we've got -2/3 x with the y, and that is equal to -8. And then once it's organized in standard, all we have to do is make sure it's written properly. So we want to make sure that that leading term in front of the x is a positive whole number and that we don't have any common factors. Well, that's definitely not a positive whole number. So we have to fix that, right? So we're going to multiply through and create an equivalent equation, which is what we're doing every time here, that we multiply through. We're creating an equivalent equation that is written properly. So first thing I got to fix is the sign. So I want to make sure that whatever I multiply here is negative, so that when I do a negative times a negative, the result is a positive a value. And then the other thing I need to do is get rid of this fraction, because that's not a whole number. And so also fairly simple. To get rid of a fraction, all you have to do is multiply by the denominator, right? So the denominator is 3. When I multiply that in, that's going to guarantee these guys to cancel out. Okay, so when I multiply by that first one, I'm going to end up with negative times a negative is a positive, and then the 3/3 will cancel. Okay, so let's go ahead and do that multiplication. I'm going to distribute that all the way across. That's the big thing. So again, negative times a negative becomes a positive. The 3/3 cancels. So I'm just left with that positive 2 in the numerator, so positive 2x. Or if you actually multiply this, you'll get -3 times -2 is 6. 6/3, that's still 2x. So that's that. Then -3 times y gives us a -3y. And then that equals, last but not least, -3 times a -8 is a positive 24. 2, 3, 24, those don't have any common factors among all three. So that is properly in standard form. Okay, so move the x term to the left and then just multiply through by whatever you need to make sure that you're in that proper standard, and that is it. Okay, all right. C and D are in point slope form. Okay, so let's talk about what are the steps point slope in order to get it to standard. So, well, the big thing here is, first of all, the easiest way is to take that point slope and turn it into slope intercept. So, which we've practiced before, by the way. So change it to slope intercept, which we will review in just a moment, and then do these two steps, right? So we learned in the last unit that I could go from point slope to slope intercept in 2 steps, distribute and move the 4. So those 2 steps is all it requires. If I distribute the -2 and move the 4, I am in slope intercept. And then once you're in slope intercept, then all you have to do is these 2 steps. Okay, so after you put it in slope intercept, then it becomes what you had up here. Move the x term. And then, so put it in a proper form. Okay, so let's practice that. Let's start with C here. So this is in point slope. The first thing I'm going to do is put it in slope intercept. That's review. We've done it before. That requires 2 steps. Step 1 is to distribute the slope so that we can get rid of the parentheses. And when we do that, we'll get negative 2x minus 12. And then step 2 is to move the number that's with y. So we'll move that 4. So that was all review. We did that in the last chapter. That cancels. And those 2 steps get us in to slope intercept. So that is the slope intercept form of our equation right there. Okay, so again, just a review, to get from point slope to slope intercept, we distribute and then we move the constant. So y is by itself. Okay, now it becomes like problems A and B. Okay, once we have it in slope intercept, then we just follow this format, right? Just move the x term and then make sure it's in proper form. So let's go ahead and do that now and get to standard form. So we're going to move the x term by doing the opposite sign. That cancels. And so I've got a 2x with the y now, and on the other side I've got a negative 8. And then I just need to make sure that this is in proper form, meaning I have a positive whole number and that all of these don't have a common factor. Well, positive 2x is already a positive whole number, and 2, 1, and negative 8 don't have any common factors. So that was it. We are done. And this is the standard form. This is the slope-intercept form, and that's the point slope, all of the same equation. But that's our final answer. Okay? So I would say go ahead and pause it here and try D here and see how it goes. So press pause, try it out on your own. And if you're watching this, then you paused it, you tried it, and now you're checking your work. So the first thing is change it to slope-intercept. So I'm distributing the 4 and now moving the 2. And that gets us into slope-intercept. And now I go into the next phase of this, which is move the x term and make sure it's in proper form. So now I move the x term to get into standard form. So now I've got a negative 4x with my y and a negative 22 on the other side. I need to make sure this is a positive whole number, and it is not, so I'll fix that right now by simply multiplying through. You could also divide through by a negative 1. By the way, I like to multiply, but it doesn't matter. If either you divide everything by a negative 1 or you multiply everything by a negative 1, the whole point is just to make sure you do all of the terms and that they all change sign. As long as you change the sign on all of your terms, it's still equivalent to the original. There it is. So the standard version of this equation is 4x minus y equals 22. So hopefully you got that on your own when you tried it. And if trace your steps and look at the work and see what you need to adjust, okay? All right, so let's look at the other side. So what we have been doing every time, especially in the second phase, actually, let me clarify. What we've been doing in that last step, when we say put it in proper form, is we have been creating what we call an equivalent equation, okay? And an equivalent equation is basically 2 equations that represent the same line. So if I say 2 equations are said to be equivalent, if they have the same solutions. Equivalent equations can be found by multiplying each coefficient of an equation by the same constant or dividing by the same constant. Basically, as long as you do all of the terms, both sides of the equation, whether you multiply them by the same number or divide them by the same number, you create an equivalent equation. If we were graphing it, we would get exactly the same line. Okay? We're just writing it differently. Okay, and that's what we're doing when we make sure that it's in proper format. So let's practice just creating some equivalent equations here, right? Two equations in standard form that are equivalent to the following. And I'm actually going to adjust that those directions a little bit. We don't need to do two. What I really want y'all to practice more than anything is writing the proper standard. So what we're going to do is look at these guys here and practice writing in proper standard form. Okay, so write in proper standard form, okay, so that you have equivalent equations. So let's take a look at this one right here. Remember, proper standard basically means that you have a positive whole number here and that there's no GCF. Okay, well, I do have a positive whole number, but I want you to notice that 2, -6, and 4 are all divisible by 2. So they do have a common factor. That's what we're going to want to fix. Okay, so this isn't quite in proper standard because there's a GCF of 2. So let's get rid of it, right? As long as you either multiply or divide each of the coefficients by the same thing, you're still okay. So I'm dividing all of these by 2 to create our proper standard. So if I divide through by 2, 2x divided by 2 is just 1x. -6 divided by 2 is -3y. And 4 divided by 2 is 2. This equation is equivalent to that one, okay? This one has just been doubled, but if I graph them, they would be exactly the same line. They would have the same points, the same slope, the same y-intercept. It's the same line. This one is written properly, okay? How about B? It says 1/2 x plus 8y is equal to -4. This is not quite improper yet because we have a fraction, right? Part of it is to have a positive whole number here for x. And so I want to get rid of that fraction. And the best way to do that is take the whole equation. And I'm going to rewrite it down here so it's easier to see. And multiply that whole thing by that denominator of 2, and that will clear. When we do 2 times 1/2, they'll cancel and I'll just get x. I'll have a whole number that is positive in front of x, and that is what we're looking for. Okay, again, the big thing is make sure you do it to all 3 terms. Okay, so when we do that, 1/2 times 2 is just 1x plus, and then 2 times 8 is 16y. And that is equal to 2 times -4, which is -8. And 1, 16, and 8 don't have any common factors. I'm safe there. This is in proper standard form. Okay. How about this last one? If we look at the last one, 8, 6, and 3, they don't have anything that all 3 would have in common, but this is negative, and we need to fix that. So that is what we're going to focus on here. We're going to take that whole equation and multiply it by a -1, or divide the whole thing. It really is up to you. I like multiplication. But as long as you multiply through or divide through by a negative to all 3 terms and change all of the signs, then this will still be an equivalent to the original. So when we do that, it changes this sign, it changes this sign, and it changes that sign. And now we have the proper version of the standard form. Okay, so just to recap, write it down here. We divided by the GCF. On this type of problem, we multiplied by the denominator. Okay, and for this type of problem, we can either multiply or divide by a -1, and it'll clear the sign. So those are the 3 most common ways that you, or steps that you might have to do to make sure that these guys are in proper form. right? You could have to divide through by a GCF that they might have in common. You might have to multiply by a denominator to get rid of a fraction. You might multiply by a negative to make it, make a positive. The other ones are okay if they're negative, but this one needs to be positive. So is each of the given equations above in proper standard form? Not originally, right? So that's the big thing. So not originally, okay? But our answers, right, our solutions are. So our solutions are, why? Because A is a positive whole number. In our answers, A is a positive whole number. And A, B, and C have no common factors. Okay, so that's really just a little practice or focus on making sure that you're comfortable putting it in proper form. After you have reorganized it, as long as you have X and Y on the same side, X goes first, then the Y, and then the number by itself, then really these are the steps you take to just make sure that your answer is in proper form. Okay, so we've practiced how to write it from slope-intercept to standard, from point slope to standard, and now we're going to practice writing in standard form if you're given the slope and some point, okay? And so step one, we're going to use the slope and that point to write the equation in point slope first. Why? Because that's what they gave us, right? So you work with what you've got. That's always my thing, right? So if what they give you is slope and a point, then let's work with point slope, because those are the ingredients we have, so that is the cake we will bake, right? And then after you have it in point slope, we already practiced on the first page how to then get that into standard, right? We've already practiced going from point slope to standard, so it really just kind of marries the lesson on point slope previous to this, like how to write point slope from this, and then marries that with today with getting from point slope to standard. So you pretty much are putting it together. Okay, let's try A here. So for part A here of chapter 3, of number 3, you've got that the slope is 4 and that it passes through the point 2, 5. So we're going to borrow that 2, 5 and make that our x1, y1, because that is a point that we know is on our line, okay? And because what I have is a point and a slope, we will start in point slope, at least at first. Okay, so we'll just insert things where they belong like we did in the previous lesson. So this will be y minus 5 equals the slope of 4 and then x minus 2. And now that we have it, then it becomes like the problems on the first page. It's just a matter of getting from point slope to standard. Well, to do that, review, right, is first put it in slope-intercept. So distribute the 4. So we'll get 4x minus 8. Okay, move the 5. Okay. And we briefly get here, which is slope-intercept. But now we're going to keep moving because we really want to get all the way to proper standard. Okay, so now that we're here, we'll go to proper standard by moving the x term forward. So we've got negative 4x with the y and a negative 3 by itself now. And then last but not least, we just want to make sure that that is proper. So we look through, no common factors here, but we do have a negative to handle, to deal with. So we will take this whole thing and multiply by a negative 1 and make sure that you do that to all. So basically what that does is it changes all our signs. As long as you change all the signs, you're okay. So that becomes then a positive 4x, a negative y, and a positive 3. And guess what? That is the standard form equation for the line that has those characteristics. Okay, if it has a slope of 4 and it passes through the point 25, this is the proper standard form equation for that line. Okay, let's try it again. You've got a slope and a point, so we're going to use that slope, borrow that point, go into slope-intercept. So that's going to be y minus my y coordinate equals the slope and then x minus the x coordinate. That's step 1. Step 2 is get from here to slope-intercept, which means distribute and move the 4. So first, let's distribute the fraction. That's a positive 1, okay? And then we'll move the 4 over. So now we are briefly in slope-intercept. Say hi to slope-intercept. Hi, slope-intercept. Good to see you. All right, we're moving on now. We're going to be out of here because now we're going to go from that to standard by just moving the x term forward. And now we have 1/3 x plus y is equal to 5. And now we are in standard. It's just a matter of making sure that this is in proper standard. And I notice right away I have that fraction. We'll want to take care of that like we practiced. So I'll multiply everything by the denominator because that'll clear my fraction. And so when I do 3 times 1/3, I'll just get 1x. And then 3 times y is 3y. And 3 times 5 is 15. That is the standard form equation for that, for those characteristics, the line that has those characteristics. Okay. All right. I would say press pause here. Try C on your own and see if you can get all the way to proper standard form on your own with the tools that we've been practicing, and then we'll come back and check it. Okay, so check to see if this is what you got. When you insert this into point slope, this is what that looks like. Y plus 2 equals the slope, parentheses x minus 8. And then we go through our steps. We distribute, we move the 2, that gets us into slope-intercept. Then we move the x term forward. That gets us into standard, and then we make sure it's in proper standard by multiplying through by 4, and this is the resulting proper standard version of the equation with those characteristics. So hopefully you got 3x plus 4y equals 16. That is the proper standard form for that. If not, go back through and look through your work and see where the mistake was. Okay. All right. So that is writing the equation from a point and a slope. Let's talk about how to do it from a graph. Okay, you have an outline here. You have a couple of, step-by-step instructions. If you're given a graph, okay, standard form on a line, you're going to find the slope, whether it's from the graph or with a slope formula, right? So this works for both, whether you have the graph or just given. The idea is find the slope. You'll always need the slope no matter what you're doing. So find the slope of the line, okay? Then use the slope and one of the points that you're given to write it in point slope, and then rewrite it to standard. Basically, it's just an added layer. The big thing is if you're given 2 ordered pairs or a graph, you weren't handed the slope like you were here. So you'll just find that we just keep adding another layer and another layer, right? So we already know where to go after you know the slope and you have a point. The only difference here is that we're going to find the slope first. The rest of it is exactly what we just did on these 3 problems, okay? So the only added layer is that we'll find the slope. And then after we find the slope, we'll pick one of the points that we know is on the line, and we'll proceed from there. Okay, so let's try 4a. So it looks like this line passes through -2, 3, and through -4, -3. So let's go ahead and use the slope formula to find the slope first. So just a reminder, I'm going to put it to the side here. Slope formula is that y2 minus y1 over x2 minus x1, looks like that. And then we will just pick one of those to be your first point. So if I start here, I do 3 minus a negative, really becomes 3 plus 3. That's the change in my y's. And then -2 minus a negative becomes -2 plus 4. So that's 6 over 2 or 3. So now we know the slope of this line is 3. You also could have used rise, since you happen to have a graph in front of you. You could then rise over run, and notice that your slope was 3 indeed. Okay, so now that I know that the slope is 3, the idea, now it becomes like the last few. You have the slope, you have not 1 but 2 points, so you can pick which one you want to use. I'm going to go with that top one, but you could use any point on this line. And then the rest of it really is just, practice again. If I have the slope and a point, we'll start in point slope, which is going to be y minus the y coordinate equals the slope, and then x minus the x coordinate. That becomes a positive. And then we'll distribute. We'll change it into slope-intercept from here. So we'll distribute the 3 and move the y coordinate. So we get y equals 3x plus 9. Okay, and then to get that into standard, we'll just move the x term forward. So we get negative 3x plus the y equals 9. But that's not quite in proper standard, so we'll just multiply through by that negative 1. And our standard is just the opposite sign of all of this. So 3x minus y equals a negative 9. That's the standard equation for this line that is on our graph, and the one that has those characteristics. It's 3x minus y equals negative 9 is the equation of that line in its proper standard form. Okay, so go ahead and try B and C. Try those out, and then you can check your answers. Okay, so check your work on these. When I did the slope here, I got a rise of 3 and a run of 2, so that's 3 over 2. And then I borrowed one of the points. I used the 4, negative 2, but it shouldn't matter which point on this line you pick. I put it into point slope, so here's point slope right here. Then from point slope, I moved it to slope intercept by distributing the fraction and moving the 2. And that got us into y equals 3 over 2x minus 8. And then by moving the x term forward, I get into standard. I notice I have a negative and a fraction, so I get rid of those by doing a negative and the denominator. So multiplying through by the negative changes it to positive. It also changes my other signs. And then multiplying through by the 2 clears the fraction because I just get a 3. So this is the standard version of that line. Okay, and then on C, I got a slope of negative 1, and then I used the 3, 6 point, put that into point slope, and then again just distributed the negative 1, moved the 6, that gets us into slope intercept, and then all I had to do was move the x forward, and I'm in standard, and actually in proper standard. This one already landed in proper standard, and it was ready to go. Okay. Alrighty, let's finish out with some vertical and horizontal lines. These are actually a lot simpler, and I want you to think about what we're going to do here, because if you understand what we're doing, this becomes really easy. So it says write the equation for horizontal and vertical lines that pass through the given points. Okay, so the big thing I want to remind you is that when we're dealing with vertical and horizontal lines, we are going to, if it's a vertical line, it's going to be x equals, and then just whatever the x value is, which is the x-intercept that vertical up and down line is intersecting. And then the horizontal line is going to be an equation that says y equals, and then the y-intercept. We've played with those before, but I just want to remind you that those would be the examples where one of these is going to be a 0. So back when I said earlier, on the very first page, when we looked at standard form, this is a situation where one of these would be 0. If it's a horizontal line, that means that A was 0, and all we're seeing is this version, the y equals, and then the number. And if it's a vertical line, and all we're seeing is the x term and the constant. Okay, so these are those special cases. And they're really easy, because if you have an ordered pair that you know is in one of these lines, then you are actually already seeing the coordinate you need. This is why. So I'm going to do a little graph here so you can see what's going on, kind of off to the corner. Let's say I have the x and y axis here. And let's pretend, well, let's do this one right here. So it says it passes through the point negative 1, 6. So that means I go over to this side negative 1 and up to 6. So what this is telling me is that my vertical and horizontal line, I'm going to do one of each, passes through that point. Okay. Well, let's think about it. Let's start with the vertical line. If I have a vertical line that passes through the point negative 1, 6, well, then that vertical line is this vertical line right here. And that vertical line would have an x-intercept of exactly negative 1. In fact, it would be directly, the x-intercept would be directly below that point, right? So this would be the vertical line that is passing through the point negative 1, 6. Well, what's the equation of that line? It's just x equals negative 1. So it's just x equals whatever that x coordinate is, because the x coordinate of our point is going to be the x-intercept of that vertical line, which is going to be the equation of that vertical line. So when I see a negative 1 here, and I know I'm looking for the vertical line that passes through here, that's just going to be this line right here. Now, let's explore the same thing, but with the horizontal version of that. So if we look at the horizontal version, same point, negative 1, 6, right? The horizontal line that passes through that point would be right here. Okay, it would be a y equals line, and all I would need is the number that is the y-intercept. Well, where does this intercept the y-axis? At 6, right? It would be lined up also with our point. So it would be at y equals 6, right? And so the horizontal line that passes through negative 1, 6 would be y equals 6. So it actually is just the coordinates you see. So our point is not on the intercept, but we know that if we pass a horizontal line, the equation of that line will be the x-coordinate, because the x-coordinate is also the y-intercept, and the y-intercept is the equation. Okay, and so that's all you have to do here. This is why it works, right? But the moral of the story is, if you want the vertical line, or the equation of the vertical line that passes through it, it would just be x equals negative 1. If you wanted the equation for the horizontal line that passes through that point, it would just be y equals the 6. Okay, and then if you understand this, you don't necessarily have to make a graph every time. If I want the vertical line here, right, then I know it's just going to be the line where x is always equal to negative 5. So that would be the equation of my vertical line for B. And for the horizontal, it would be the equation of the horizontal line where y is always equal to 7. So it would be just y equals 7. Okay. Last one, 2, 1. Okay. If you want a vertical line that passes through the point 2, 1, I know the vertical line would be the vertical line that where x is always 2. Okay. And the horizontal line would be the line where y is always equal to 1. So really, you're just taking the x and y coordinates and using them as the equation of the line, because of those characteristics that are true for those equations. And so that's how you would write the equation of a vertical and horizontal for a point, for the lines that pass through a specific point.